Welcome everyone to another lesson on Khadija Academy. Before we start this lesson, hit the subscribe button, the notification bell, and the like button for the YouTube algorithm. Now let's go and start our lesson. Hey everyone, in today's lesson we will start discussing types of pitch windings or pitch inside the electrical machines. So the types of pitch is very helpful in understanding how are we going to draw our lap and wave windings, okay? So starting with number one, looking at this figure, here we have two figures, right? One representing lap winding and the other one representing wave winding. Now, as you can see, in order to move from this to this one, from this side to the other side, there is a certain distance between them. This distance is measured in how many segments or how many coil sides, okay? So the distance between them here is YB, and you can see we have YF, YR, and etc. Similar here for this one. So let's understand each of these terms. So number one, let's look at this. We have back pitch. Back pitch here, or YP, what does this represent? This representing the distance between the two coil sides of one coil, and it must be an odd number. This is very important in your own design. So what I mean by this, as you can see here, let's say for example this one, let's use this one pen. Okay, let's go here. In this part, you can see here that this one is in slot number one. Okay, so I'm going to take it from here and to go all the way back to reach the other side, right? So the other side. Okay, this one, let's say at slot number three, slot number four. Okay, not three, slot number four. Now remember that we said before that our winding inside the slots, we have upper layer, lower layer, upper layer, lower layer, upper layer, the lower layer in double layers, okay? You can see that the upper layer is 1, 3, 5, odd number, and the lower layer 2, 4, 6, and etc. Now remember that we have one side, remember we said one side on upper layer, the other side in the lower layer. So one here on 1, for example, and the second one in 4. Okay, so one in upper layer, solid line, one in the lower layer, dashed line. Okay, now as you can see the distance between them, how many slots between them? 4 minus 1 equal to 3, right? So in order to change from upper winding, upper layer to lower layer, or from lower layer to upper layer again, we need what? We need an odd number. That's why the distance between these two is odd number. So here you can see 4 minus 1 is 3. This one representing back pitch, okay? YP. Okay, great. So you can see that so when we are designing, let's say we started at slot number 1, in order to get to know where I'm going to connect the other side, I will say, let's say at 1 plus Y back, which we will get its own equations, okay? So as you can see here, Y back, why it is called Y back? Because we are connecting them, we are going from this side to this side through the back of the electrical machine. Back of the electrical machine. What I mean by this, look at this figure here for lap winding. As you can see, we have this side and this side. I'm connecting between them. How? I'm going like this through the back of the electrical machine, this back. Okay, that's why it's called the back pitch. Okay, similarly for wave winding, we have this winding here and the other side, and we are connecting them back. That's why you can see the side and the other side, Y back between them. Okay, so the distance between two sides. The second definition called front pitch. Front pitch, or YF, is the distance between armature conductors which connected in the same commutator segment. So as you can see here, we connected the first winding. Now remember that we go back to commutator segment and then we go to the next coil, right? So this is our first coil, and then we draw the second coil. Now the distance between the last or the second coil side to the next winding that are connected in the same commutator. So let's say, for example, I draw it, this one, added this one, like this. And then I know y back equal to whatever the number like this. Let's say it is equal to 4. Now I would like to know where I'm going to draw the next one. Is it at slot number 2, 3, 4? What is it exactly? Now the distance between this to the next coil is called YF. So for example, if YF is equal to, and of course again it must be an odd number, okay, it must be an odd number. So let's say this one is 6, okay, for simplicity, and let's say YF equal to 3, okay, YF equal to 3. So I'm going to the next coil, go back 3 slots. So I'm going from 6 minus 3. So I'm in slot number 6. I'm going all the way back to slot number 3 or layer number 3. Okay, whatever it is, as we know that each one has an upper and lower layer. So we are going to number 3, right? 6 minus 3. So I'm going all the way back to number. So this one. So if this one installed in 1, this one will be installed in 3. So Y back helps us to go forward to the next coil side, and from here we can use Y forward to go to the next coil, right? Or the next winding we are dealing, next coil side we are dealing with. Okay, you can see they are connected in the same commutator segment. Now in lab and wave winding, we have equations for YF and YB to help us decide where are we exactly going to install these coil sides. Okay, so let's delete this. This is for lab winding, Y back and Y forward. For this, same here between two sides, Y back, similar as here. And since we are progressing forward, you can see at the same commutator segment, we connect this one to this commutator segment, okay? And then I would like to know the next position of the next coil. Between them, again, YF, okay? Similar to here, between them, YF, okay? Now, there is also commutator pitch, YC, distance between the commutator segments to which the two ends of a coil are connected. So what you can see here, look at this one. Here you can see this is the first coil side, number 1, connected to this commutator segment. Let's say call it 1, segment 2, segment 3, and etc. So I would like to know, this is the first coil, right? The second coil, this second coil, where are we going to connect it? Okay, where are we going to connect? The distance between them called YC. Okay, so the first coil in commutator segment 1, second coil in commutator segment 2. In reality, in lab winding, the YC equal to 1, positive or negative. Okay, if we are moving forward or are moving backward. Okay, as we will see in the next slide. Okay, it can be positive or negative. Now for our wave winding, you can see that the first coil, this is our first coil. Okay, assuming it is connected to this commutator segment, number 1. Now you can see goes all the way like this to the second side and connected where? Connected here, right? At this one, you can see 1, 2, 3, 4, 5, and 6. So at point 6, we connected the second coil side at this commutator segment, and from the same point we start the next one. The distance between the beginning and end is YC, as you can see here, right? In this, in the wave winding, it is not equal to 1. We have an equation for this type, okay, for wave winding, okay? Now there is also a Y resultant or resultant pitch, winding pitch, with distance between the beginning of one coil and the beginning of the next coil to which it is connected. So what I mean by this, let's delete this. Beginning of the coil and the beginning of the next coil. You can see this is the first coil, beginning of first coil, beginning of second coil, distance between them YR. Or end of the first coil and end of the second coil, distance between them also YR. Similarly, you can see beginning of the first coil, beginning of the second coil, distance between them YR. Okay, now also if you draw the rest or the second side, then the distance between this side and this side is also YR. The equation of YR is simply like this in YR or Y, they are the same. In here, as you can see, that there is a Y back and this is Y forward, this is YR. You can see that Y back is equal to Y forward plus YR, right? So YR itself or Y is equal to Y back minus Y forward, like this, Y back minus Y forward, lab winding. In the wave winding, like here, you can see that YR is simply summation of YP plus YF, like this, okay? Now, for commutator pitch, we said before that this one is YC is equal to 1 in lab winding, and we have an equation for it for wave winding. Now, there is a very important part. In lab winding, it can be 1 or negative 1. Okay, it can be 1, so it means that the first side here, and we connected this second side in the after 1, like this, after 1 if it is positive. If it is negative, then I'm going to take this side and go all the way back here. Now you will say, what does this even mean? You will see right now. If commutator pitch is equal to positive 1, it's called progressive lab winding. If it is negative 1, it's called retrogressive lab winding. Now, let's see the difference. Progressive, the same one which I discussed right now. You can see we started at slot number 1 here. So this is the first coil, goes all the way to number 2. So YC here is equal to positive 1. Now from this side, we will go all the way like this and go to number 3 and then go all the way like this and continue as we did. Okay, so we are progressive forward or moving to the right, progressive. Okay, this one. In the retrogressive, it is different. We are getting to the back. What I mean by this, look carefully here. So you can see that we have this at, let's say this is number 1 and this is number 2. For simplicity, okay? You can see we started at 2, like this, okay? And then this coil side will be connected all the way back. So you can see that this is the beginning and this is the end. So you can see that YC in this case is negative 1. We are getting to the back, not forward, but retrogressive, getting to the opposite direction. Okay, so you can see we connected here and then we draw the next one. So as if we are moving in the opposite side. Okay, most of our windings are progressive lab winding. Okay, like this, you can see that this is a progressive. You can see we started at 1, go all the way to commutator number 2. Then we draw the next one like this to commutator 3 and then go to number 4. So we are moving forward. YC a positive value. If we have a retrogressive, for example, let's start from 3 to understand this. You can see that 3 all the way like this, okay, and get back to commutator segment number 2. From commutator segment number 2, we will go all the way back like this to commutator segment 1. So we are moving in from right to left. Right here, we are moving from left to right. Okay, that is the difference between progressive and retrogressive. Now there is a factor here which is important. It's called multiplicity or multiplication of parallel paths. So if I would like to increase number of parallel paths inside the lab winding, we have a factor which we can use, which is M. What I mean by M? Now remember that YC, or the commutator pitch, is inside the lab winding is equal to +1 or -1, right? +1 if we have a progressive, -1 if we have retrogressive, right? That is what we call, one is called simplex winding, just one step, simplex winding. If we have YC, instead of being 1, being 2, okay, so if we make YC here, this one, make it YC equal to 2. So instead of going like this, going from 1, go all the way like this, all the way like this, and connecting it to, no, I'm going to connect to number 3. Okay, so the distance between the beginning and the end is 2. Okay, that is what we call duplex. You can see here +2 for progressive duplex winding, -2 for retrogressive duplex winding. If we have 3 steps, and from 1 going all the way to number 4, so 3 steps forward or backward, then we will have a triplex. Okay, let's see it. +3 for progressive triplex winding, and -3 for retrogressive triplex winding. So you can see simple or single, double, and triple. Okay, simplex 1, duplex 2, triplex 3. And as you can see here, we are progressing forward like this when we draw our electrical our developed diagram, developed winding diagram. You can see that we started at 1, go all the way to, let's say, number 10, okay, to number 10, and then get back to number 3 and keep progressing forward. So you can see that 1, go all the way here like this to number 3, and then from number 3 we go all the way back here to number 5. So what you can see here, let's magnify this. You can see that we started at 1, right? You can see that here, segment 1, okay, then go all the way like this, go all the way like this, and you can see that it goes to which segment, or commutator segment number 3. So we started at 1 and we finished at 3. So it means that this is a duplex lab winding. Look carefully, started at 3 like this, go all the way like this, and we reached 5. So we started at 3 and ended at 5. So this is also a YC equal to 2, which is a duplex winding, progressive winding. As you can see, we are moving in this direction, right? So it means that since we are drawing in this direction, which is progressive, this is the direction of rotation or direction of motion. Okay, we are moving in this direction. How I'm going to move like this? If you take this machine and draw it in the circular form like this, if you say this is a commutator segment, let's say 1, 2, 3, 4, 5, 6, 7, like this. Take this part and make it rotational. You will see that we are moving from 1, progressive in this direction, from 1, 2, 3, 4. So our direction of rotation, 1, 2, 3, 4, like this. So our direction of rotation will be like this. Okay. Now, if we have 4, it will be quadruplex, too much plex in this lesson. Plus 4, quadruplex, and minus 4 for retrogressive quadruplex winding. Okay, so what are the equations which we are going to use in drawing our developed diagram? Number 1, for Y-back in lab winding. Remember, in this one, Y-back is equal to 2C, which is the Z. Remember, C is number of coils. 2C means that we are talking about the total number of conductors we have. 2C. Z over 2P, which is the total number of poles, plus M. M is our multiplicity factor. If it is 1, it means we are talking about simplex, 2 doublex, 3 triplex, and etc. Now for Y forward, it will be the same equation but with a negative sign, negative M. Now before we go to lab winding, as you can see here that when Y back, if it is progressive simplex, okay, then M equal to 1, right? So here plus 1, and this is minus 1. As you can see in this case, in progressive, Y back will be greater than Y forward. As you can see, Y back, we moved all the way from here to here, and Y forward we get like this, but with a small part, with a small value. Okay, so we moved forward larger distance than getting back. Okay, so in this case you can see that we are moving forward, right? Because we are not getting so far away. However, if it is a retrogressive simplex, it means it will be minus 1. So Y back will be minus 1. Y forward will be plus 1, because negative 1 and negative gives us positive 1. So Y back and Y forward. Now, as you can see here, Y back and Y forward, you will see that Y forward greater than Y back. So it means that if we move a certain distance here, okay, let's say 5, then in this case I'm going to Y forward will be 7. So I'm going to get back like this 7 steps, because the difference between these two is 2, right? Minus 1 plus 1 difference is plus 2. So going forward, going back. So as you can see, we are going to get all the way back. Similarly, go forward, Y back, and then Y forward will get us back again. And so you can see that the direction of rotation or motion will be to the left. Okay, this is for lab winding. Last point before getting to this one, we said back pitch because we are connecting through the back of the machine, right? This is from this coil to this coil, back. Similarly here, back of the machine. Why it is called Y front? Because you can see from this side to this side, we are connecting like this from the forward of the electrical machine. You can see that here, from this side to this side, we are having their connection at the front of the electrical machine. That's why it's called the front pitch. Similarly here, as you can see in this one, you can see that we have this coil, and we go all the way and connect to the next side from the front. So this one is called Y front because we are at the front of the machine. Y back because we are connecting at the back of the machine. Okay, for your own knowledge. Let's continue. So we discussed the lab winding. Now what about equations for wave winding? In wave winding, number 1, as we said before, Y back and Y forward are odd numbers in order to switch between upper layer and the lower layer. Okay, It is possible when we have odd numbers. Now they can be in wave winding similar to each other or can be different by 2. Now how can we get them? In case of being equal, then y back will be y forward equal to y average. So what is y average exactly? Y average is y back plus y forward over 2, or we are going to use this equation here. So this is representing number of conductors, Z, plus or minus 2 divided by number of poles. Okay, so we can have two solutions. One solution, which for example can be, let's say 8, and let's say difference between them, let's say 5, okay, whatever the value, okay, for simplicity. So if the answer is 8, okay, which is an even number, what we can do in this case, if y average equal to 8, which is an even number, remember that y back and y forward are odd numbers, and they can be equal if they are odd numbers or differ by 2. So what I'm going to do is that I'm going to choose two odd numbers close to 8 and differ by 2. In this example, we can choose 5 and 7. Two odd numbers separated by 2 and very close to 8. So we can say this one is y forward and this is y back. Or you can do the reverse. You can say 5 is y back and 7 is y forward. One of these will give you a progressive or movement in a certain direction, and the other one will give you an opposite rotational direction. That is the difference between these two. These solutions, both of them are acceptable. Okay. Number 2, if we choose 5, y average equal to 5, then I'm going to use this equation here. Y average equal to y back equal to y forward. Okay, so we are going to choose y back equal y forward equal to 5. Okay, this is when we are solving the winding diagrams. As you can see here, in case of they differ by 2, y average is an even number, then it will be y back plus 1, y forward minus 1. As you would like, you can do the reverse, but we generally use this. And remember that YC, or the distance between two commutator segments, equal to Y average equal to 1 plus or minus 1. Remember in simplex, okay, in simplex, YC is equal to a plus or minus 1. Now in the wave winding, distance from here to here, YC commutator distance, commutator segment distance between them is Y average, which is this equation. So if Y average is equal to 8, for example, then YC will be equal to 8. Distance from here, 1, 8 segments, it will be 9. Okay, so we learned how can we get Y back, Y forward, dependent on the value of Y average, and YC, or the commutator segment distance, will be equal to value of Y average. Okay, so I hope in this lesson you understand now the different type of pitches inside the DC machine, and now we can be able, or we can draw our winding or developed diagrams for lap and wave windings. Thank you for watching this lesson. I would like to invite you to our academy, Khadija Academy Premium membership, which will help you learn more about electrical engineering. In this academy, or in the academy membership, you will find that we'll have more than 100 courses in math, electrical engineering basics, power engineering career preparations. For example, we have electrical design, we have courses on electric circuits, power electronics, ETAB, MATLAB, solar energy, wave energy, wind energy, and much more. You will find also in this academy, you will find the different feedbacks from some of our students that joined our courses. You can, for example, join our membership for just a small fee per month, or you can just have a lifetime access in which you will get all of current courses and classes, and you can have them forever. And not only this, but any new courses that will be created, you will be able to watch it for completely free. So what are the classes that I will learn in this membership? You will find different classes in electric circuits, you will find in transformers, magnetic circuits, machines, power electronics, load estimation, lighting design, lightning also design, earthing system, cables, generators, light current systems or low current systems, off-grid design, on-grid design. Very lots of classes and courses in different topics. Okay, and you will find that inside, when you join this membership, you will find this blueprint that will guide you in which classes you will start with when you join this membership. So thank you, and see you in our membership on Khadija Academy.